Hello, everyone. I am Sagar Arora, the one who you don't know me. I am a solutions architect at OpenAirInterface. And so I'm going to moderate this session. So our first speaker for this session is Turker Yilmaz. He's from 6GSpaceLab from the University of Luxembourg. He's gonna talk about he works a lot in the end-to-end projects, in different end-to-end projects, and today he's gonna present a summary of different projects in which he works, and gonna emphasize one of the projects which is pretty interesting. Yeah, Turk.
Okay, hi. My name is Turker. I am from University of Luxembourg, and I would like to present our use of OpenAirInterface in the subject of space communications, give a general overview of what we have been doing during the last 5 years. I have started working. SnT is like an institute similar to our community center. We only have master students and above. University of Luxembourg under SnT, we have the SIGCOM, Signal Processing and Communications Laboratory, and under that we have our own laboratory called 6GSpaceLab, where I will explain OpenAirInterface related projects of ours. I have joined at the end of 2022, so whatever I have done is after that, and mainly I started contributing since the Engage. Once you go, OpenAirInterface is both a blessing and a curse. And after my postdoc, after my PhD, I started working at Eurocom. So I knew OpenAirInterface, but was new to the satellite communications. And normally, this was just supposed to be a general agenda, and I was just going to spend like 30 seconds, etc., on this slide. But I think space communications might not be very or new other than Thomas. So I would like to give a little bit of information on the projects to give a general overview of this idea or the vertical. 5GSpaceLab is how this laboratory was founded, all the USRPs, etc., was bought, etc. And I remember at the end of 2022 or 2023, the demo was there was a Moon rover at another laboratory, and we were using OpenAirInterface to give commands to that. And it wasn't possible to do any channel emulation, etc. And the delay was done by introducing a sleep command in the Ubuntu of 1.25 seconds, etc. So OpenAirInterface has come a very long way since then. 5G Go and Leo has been, as far as I know, the main projects where the current state of the release 17 compatible NTM features are coded and merged. I have done little there, and here I want to make a point. I mean, that is also related to the main project that I would like to talk, which is 5G nano satellites, where we will try to actively contribute here. The contributions were done, but not merged regularly. So when we did rebasing, etc., there were infinite number of conflicts, merge conflicts, and unfortunately for Thomas picked the short straw, and he spent an infinite amount of time in order to solving all of them and merge the features into the repository. So this is a point that we have learned our lesson, and we will not repeat. The Engage project is where we had access from the SES, which is another Luxembourgish company, of a little bit of satellite capacity, where we have used OpenAirInterface, transparent satellite GEO, G0B, UE, and did a test, etc. We basically did ping and hyperfront, just to do a proof of concept in a way. But here, this point that I would like to make is that it is hard to get a channel emulator for satellite communications. It costs at least 100,000 euros. It is very hard to find a satellite capacity in geo orbit. It is impossible to find LEO capacity anywhere. As far as I know, there is only one or two ESA's LEO satellites, that is experimental satellites, where you might be lucky enough, but I mean, they pass once for 10 minutes every day, and it is not open to everyone. It is very hard, etc. So it is more or less impossible. And the problem is that, I mean, maybe another point here, this will be like my psychiatric session, but I would like to say my pet peeves in the sense that, I mean, generally people, I mean, there is this meme like USA number one. In space communications, yes, obviously there's Starlink and there's nobody else. In research projects, I see a ton of geo, MEO involving stuff, but when if I'm not mistaken, in May of 2026, they have surpassed 10,000 LEO satellites in orbit, actively working. Next year, they will have their DTC satellites flown. At the beginning of this year, they got permission from FCC for another 7,500 satellites. Their final aim is 42,000 satellites, and there is absolutely no competition there. So when you ask for LEO satellites, etc., for example, STS is one of the largest companies in this domain. They have absolutely 0 LEO satellites in orbit. They have plans, etc. When you talk with ESA or any European Union official, etc., they say they talk very highly about the IRIS², but their final constellation will be 200 and something, less than 300 satellites. So it is, I mean, and in this FCC, Starlink also asked for, I mean, normally you would expect a LEO satellite to be around 550 and 600 kilometers, but now in that permission they get from 380 kilometers to 500 something. So they are even trying to go lower. It obviously will increase the Doppler, but I guess they trust in their system. So in order to save from the latency, they might be going that way. ITER project, I will talk about it. 5G nanosatellite, I will talk about it. 5G emerge is where it is like the, okay, Raymond is not here. EBU is the prime, and we are trying to code a little bit of MBS, multicast broadcast services, inside the OpenAirInterface. The idea is to have an unregistered UE to be able to directly communicate with the satellites. Cosmic is direct-to-vehicle for SES, and I will talk about it. It's already been 6.5 minutes, so let's move on. For the ITER project, I want to make two distinctions. I mean, because this is OAI related, I want to make two distinctions. One, the research-related projects like ITER or REMOS, etc., the main aim is generally publishing papers. So we are just trying to make some ad hoc novel algorithm implemented in the OpenAirInterface, and it is not possible to merge into the develop. And when we encounter any problems, I mean, at least I am lazy, so I just try to hardcode my way out of the problem rather than solve the main cause behind it. So, but what I was trying to say to Raymond is that if there was, for example, we have coded this intelligent handover algorithm. I mean, the assumption for this project is that, I mean, the motivation for all of the space communication, the theoretical research projects is that in remote or rural areas, you will not have connection, so you need a satellite to have a backup, etc., etc. So the related innovation here was that we would have a TN to NTN handover with an intelligent algorithm that will increase the energy efficiency, etc., all of the hot topics in order to get the funding from the ESA. And the targeted KPIs, this is the demo is on OpenAirInterface, and the targeted KPI was 7.9 service continuity and reliability. I mean, I'm happy with 1.9, or you can even take the 9. I'm happy with 1.8 service continuity and reliability with OpenAirInterface, but this is what we had. This is not commercial, so the handover is done over F1 interface, because at the beginning of 2025, only F1 was available. CU makes the decisions, all of the algorithm-related decisions. Channel emulator combines the downlink give to the receiver port of the UE and distributes the uplink and gives to the other two USRPs so that we can simulate NT. And this is the general stuff, I mean, related to the handover algorithm, but I mean, not that important. Implementation in the OpenAirInterface, for example, what I was trying to say is that, I mean, if there are other verticals, for example, for the 5G emerge project, it will be an MBS code. For this project, we have a vertical endeavor. Of course, it is not mergeable, but if other people are doing coding in OpenAirInterface in other verticals for research projects, etc., if there was like an app store where you pushed your repository to there and people can check, of course, it is not going to work with the most recent developed branch, but with a little bit of instruction, clone the 2025 week 24, run these commands, and you will have some kind of an experimental version of the vertical handover that is working, etc. It would give ideas to other people, maybe. So that's what I was trying to say to Raymond before. So this is one of my points regarding to that. And this is, I have looked at these Outlook terminals more than I would like to admit, but yeah, when you put a channel emulator with the FPGA board, Xilinx, etc., people get interested, and with the satellite scenario generator from MATLAB, it always takes some interest, and you can hide whatever you are doing on the background. So what we want to do this year, this is another research project, REMUS. It is, again, multi-orbit handover, master node, secondary nodes. For this, the point that I would like to make is that we have seen that Cedric has pushed the NRDC branch. So for this project to work, NRDC has to be there, and whatever we are going to do, we will do. But our aim, again, will not be coding the exact stuff to be merged into the develop, but write papers, etc. So this is a conundrum that we encounter all the time. But this is the main project that I would like to talk during the last, or the second part of my presentation, which is 5G nano satellite. And the prime is Altis Labs. I mean, the Portuguese always all know. And the CubeSat hardware is done by the IST. So it is Portugal-led, and we are supposed to be coding the OpenAirInterface side in order to make this thing work. And the system is that there will be 3G node bees, 2 in mainland Portugal and 1 in one of your islands. And the UE will be sent at the end of, I mean, the current schedule is that at the end of next year. However, we shall see. The numerology is like, I mean, we are calling it 5G nano satellite, but it is basically 4G numerology that is being run over NTN, and by virtue of that, I guess we can call it 5G. And for the 6G stuff, I will leave Thomas to explain what is 6G. So the thing is that this is a commercial project, and starting from next week, we will need to be pushing branches and our code into the develop branch weekly if we are to be successful. Altis Labs wants to make this a product. They have cloned B205. Okay, what is going to work in this 3U CubeSat is that our RF is a clone of B205 Mini. Then it will be run by a CM5, RPI CM5. At the moment, RPI CM5 is powerful enough to run NR soft modem or NR UE soft modem in real time. Of course, if you are not going to try to run like 100 megabits per second of data through it. So for our purposes, for this kind of a throughput of only 1 megabits per second, it is good enough. And then there will be another board which will be running on CM4, which will connect to the camera, and that will be the video feed. And we will, with that feed, we will control if our system is able to give the data from NR-UE soft modem in orbit to 3G node bees with the handovers also happening. This is what we will try to do. This is our plan for the next 1.5 years. Next week on Tuesday, we have the ESA kickoff meeting for this technology phase. So, I mean, these slides are coming from that. From this moment onwards, it is a wall of text, but I mean, I will not, of course, I will not talk about all of them in detail, but I would like to point out a couple of points. Not these, but here. So, for example, at the moment, OpenAirInterface is research-oriented and at low TRL. But for this to be a commercial product, we need to increase the TRL. Here, for example, normally when UE crashes, and it crashes a lot, then you can do Control-C and restart. However, Even Elon Musk doesn't have his private spaceship to go to LEO orbit and restart. So we need a watchdog. Can we code our UE watchdog and G0B watchdog and push this inside the OpenAirInterface repository? Because, I mean, yes, this is not standardized in 3GPP, but T-Trace is there, and it is not standardized also. And we would like this code not to die out, but stay there. So, I mean, this is one of my points that I would like to make going forward. I mean, this, I think, would be, I mean, this is important for us, and if we can do that, that would be great. Another thing, we would like to enhance the RF simulator. MATLAB is, I mean, when I was at Turker, MATLAB was our gold standard, and I assume it is still the same. And we would like to make the RF simulator as good as the MATLAB, at least for the link level. Would a network simulator be feasible? Thomas, for the first time, as far as I know, has introduced the mobility scheme. However, it is the first iteration, and it is constant. So we would like to introduce our own, for example, a custom TLE data, etc., etc. So in another work stream, we will be working on RF simulator, and in our minds, I mean, if we go 110%, I mean, we will be able to do a network simulation over our simulator. I mean, the project would be good enough if we have the link level simulator, but I mean, so for the CM5 UE performance and transport, in order to check if the RPI CM5 is good enough, I mean, our hypothesis was that probably LDPC was going to crash the OpenAirInterface, and it would not be able to run real time. However, I checked, and Raymond was the person who did these SIMD extensions, so it works, obviously. Therefore, at the moment, with the low MCS, etc., it works in real time. However, for example, maybe I can break the wall of text. This is from one of our recent papers. I mean, it is just experimentation, but what we have seen is that USB is taking a ton of time instead of the LDPC decoder, etc. So maybe we will try to find a different driver for the USB, a custom one. It doesn't, I mean, because it's going to be a product and not that important, but for the downlink or the LDPC decoder, we would definitely be trying to avoiding coding a new optimized version of the LDPC decoder, etc. However, obviously, increasing the LDPC iteration would gain us some block error rate. And link budget is always, especially for CubeSat, but in satellite communications, link budget, I mean, you calculate the link budget at the beginning, and it never closes. So, I mean, this would help. For the NTM, what we are going to do is that SIB19 NTM fields, some of them are there, but I have OCD, so I would like to have all of them. But of course, we will need, in order to be able to do conditional handover, for example, we will need the distance threshold, etc. I'm not so sure about the polarization, uplink, downlink, etc. But for the distance threshold, etc., or reference location, we will have the GNSS location on the UE. So we will have a full SIB19 at the end of this. Moving on, Doppler compensation, maybe we can have a better Doppler compensation. TA, this thing I was also talking with Raymond. When we test, in our case, and for example, for the timing advance or end-to handover, FTD handover doesn't work. And the current branch, it passes all the tests, etc., but obviously we need to add more harsher tests, not just smoke tests, but harsher tests. So they were happy with us if we were to come up with those tests and JSON files, etc. So this is another thing. But the TA Doppler handover, for this project we will use end-to-hand handover. Okay, I'm running out of time. Handover. PPS, PTP, not a little bit specific. So and this is how the project would end. So I am running out of time, and thank you very much.
Yeah. So any questions?
Yes, so I'm very surprised you put the B205 Mini on the satellite.
Okay.
You must have added some kind of RF front end, no, to get the link budget, no?
Of course, there's power amplifier and the full duplexer, etc. That are all custom.
Okay.
But those are going to go into the CubeSet. Currently, it just works out of the box. We don't do anything. We just build, compile like it is. I think maybe you need to change it. If you are using Raspberry Pi OS and if it is Debian 12 or 13, maybe you need that.
No, I'm talking about the link budget. Is that satellite in space already?
No.
Ah, okay.
The plan is that we will finish all of these editions by the end of next year. We have 18 months, but maybe 180, who knows? So, and after that, it will be sent into orbit, and then it will be a real UE, 3U CubeSat, NRU soft modem running there, G0B here, and.
Okay, all right. Looking forward to that presentation when we see that in orbit.
Me too. I don't know who's going to do that, but yeah.
Okay, any other questions? If not,
Yes. Probably for engineers, it would be important to make a simulator between the baseband unit and the radio driver like USRP, because you need to simulate high delay or whatever, but also use a real radio. So it's important at some point. Satellite, each test is very costly, so you should test before.
Yeah.
Do you think you will make that simulator?
Sorry, I missed the first part. What was good?
When you test today with OpenAir, you test either with RFSIM, for example, either with True Radio. But there is nothing in the middle. And so, if you want to simulate, for example, the delay of NTN, you need a real-time simulator between the baseband unit and the true RF board.
Yep.
And with that, you can make a large range of tests that is not possible today.
Yep. In this Xilinx board, this is an in-house developed channel emulator. It is supposed to do constant and variable delay, plus it also introduces some channel attenuation, etc. They get the coefficients from the MATLAB.
So you've done it where?
This is a ECU 111 RF SOC board from Xilinx. And there is another group that is working on this FPGA. So that, we have a...
Oh, okay. So, yeah. So my idea was a bit different. It is to make just a piece of software that from the baseband unit behave as a RF board, and from the RF board behave as the baseband unit.
Yep.
I have done it in the past for another project with HAPS, not satellite, but HAPS, and it was quite efficient to test the timing advance at more than 100 kilometers. For example, I had no idea. I would love to see that code, and that was my idea regarding the verticals of the Ether project or other project where people develop something that is not mergeable inside the develop. But if there was a catalog, then I would have checked and have seen your code, and it would have helped me immensely. But at the moment, where am I going to look? But that I have done for Amarisoft baseband unit for a company that paid me. So
okay.
You will never see it, but
okay.
But in OpenAir we can do.
okay, so thank you so much, Turker.
Thank you. Cheers.
With this, I would like to welcome